Hello everyone. In this video I'll show you about Batten column design, and this is solved example problem. So in the question, the channels placed back to back. For these channel sections we need to design Batten column. By using bolting we are going to connect these Batten plates, and both ends are hinged, the condition they given, and the load is 1400 kilonewtons axial factor load, and the spacing between the channels is 220 mm. So for this problem we need to design batten plates. So in this, the solution is, here I am choosing the design of column selected. I choose the channel section, that is ISMC 350 at 413 Newton per meter, which is available in steel tables book. So I choose two ISMC channels. So on the D is nothing but DRS dash, that is spacing between the channels, that is 220 mm. Now I'm going to find out the slenderness ratio KL/R, that is 1.1 into, already given in L value is given in question, that is 10 meters, so 10 into 1000, and 1.1 is the K value by 136.6 value, that is for ISMC 350, which is R value is 136.6, which is available in steel tables. So I got 80.52. After finding the slenderness ratio, distance between centers of channels, okay, for that distance we need to find out the S value. S is nothing but spacing 220 plus 60 is the gauge distance. I'll show you it in diagram. Have you seen this? Okay, here this is intermediate batten and this is end batten. For this we need to find out the spacing. So S be the center of the channels. So 220 plus 60 plus 60, that is nothing but 220 means the spacing is this one 220, and the gauge distance is nothing but from here to this bolt center, that is 60, and here to here, that is 60. Total 220 plus 60 plus 60. Okay, next, after calculating this, we need to calculate design of battens. While designing battens we need to follow the IS 800 2007 specifications. So that is C be the spacing of the battens. From batten to batten how much distance we need to provide, we need to know. This is the C value, okay, from this batten to this batten, C. So spacing between battens, that is C by RYY less than 50, the condition is. So RYY value is available in steel tables book for ISMC channel section. By using this RYY value, I calculate C value, C less than 1415, and another condition is C by RYY less than 0.7 into KL/R. So by using this equation I am calculating C value. After getting these two values, I am selecting spacing value is 1415. Okay, after that we are calculating transfer shear. These are the design conditions which is specified in IS 800 2007. So VT is transfer shear, 2.5% axial load. So 2.5% means 2.5 by 100. Axial load we know that which is given in question 1400 kilonewtons. So I got 35,000 newtons. So after that VB value we need to calculate. Here in code book I will show you. This is this VB VTC by NS along the column axis, and moment we need to calculate the designs specifications, VTC by NS. So VT value we know that 35,000, C is 1415 which we selected, and N is number of parallel planes, that is 2 parallel planes, and S value is 340. Here we calculated that. Like that I calculated VT value, I got this one. After that moment value we need to find out. So moment M equal to VTC by 2N, I got this value. Okay, after that we need to calculate size of the battens. So for size of the battens, first we need to find out effective depth of the end batten. So effective depth of the end batten means this is the batten plate, okay, this is the effective depth, and this is the overall depth. Overall depth means from here to here, and effective depth means from this point to this point. So for this we need to calculate effective depth by following the code formulas. Effective depth is nothing but h dash plus 2 into cyy. H dash is nothing but spacing between the channels, 220 plus 2 into cyy value is 24.4, which is available in steel tables book for channel section ISMC which we chose. So I got 268.8 mm, so I provided 270 mm. After that, overall depth formula is effective depth plus 2 into gauge distance. So in the gauge distance I provided 35, so that equal to 340 mm for battens. Okay, after that this is for end battens. After that we need to calculate intermediate battens. So intermediate battens effective depth formula is 3 by 4 times this 270. 270 is nothing but an effective depth of the end batten. Okay, this is specified by code. So I got 202.5 mm, I provided 210 mm. After that, overall depth equal to same formula, 210 effective depth plus 2 into gauge distance, that is 280 mm. Next, thickness of the battens. So thickness of the battens, the code is specifying that 1 by 50th times into 340. 340 is nothing but the value which we calculated, that is the overall depth. Okay, I got 6.8. So I am providing 8 mm thick plates. After doing all this, we need to check the stresses in batten plates. I mean, by applying the 1400 kilonewtons load, how much stresses is applied in batten plates. So for that, shear stress. So shear stress formula, we know that here the stress value we got VB 841925 by load by area, 280 into 8. Okay, 8 mm is thickness and 280 is the length, that overall depth. So I got 24.05. The code is specified that it should be less than Fy by root 3 into 1 by 1.1. Hence it is satisfied. Next, bending stress. And bending stress formula is 6m by Td square. So 6 into m value already we calculated. Here we calculated the moment. So m by T into D square. T is thickness and D is that depth of the plate. So 280 square. So less than 272.72, which is this value. Hence it is okay. After that, we need to connect those batten plates by using bolting. So I am using 20 mm bolts. For that, for the threaded portion, I calculated this 0.78 pi by 4 d square. Already we know the area value, and 400 by root 3 into 1.25. This is ultimate strength of the bolt FUB value, that is 400 root 3 into gamma MW. Sorry, gamma MW, that is 1.25 partial safety factor. This is available in code book, this formula. So I got 45272 newtons. So I'm not calculating the bearing, which is much higher. So I'm taking a bolt value as 45272. Why? Because every time you are considering the least value when calculating the shear and bearing, obviously we will get the bearing much higher value. That's why I'm not calculating. So bolt value is 45272. After calculation of these bolt values, we need to find out the how many bolts we need to use. So number of bolts required, that is 17500. That is nothing but 17500 is nothing but we are having the axial load, I mean VT, transfer shear is 35,000. So here we are distributing the load equally. So 35,000 divided by 2, that is 17,500, and the bolt value. So I got 0.386. So I am providing 3 bolts to take into account due to stresses and bendings also. Okay, to avoid the stresses and bendings, I am providing 3 bolts. Okay, instead of 0.386, I am providing 3 bolts. So now I am going to check force in each bolt due to shear. So due to shear, how much force is acting on each bolt? So 17,500 already we know that is the shear by 3 bolts. So I got 5833.3 newtons. After that, let the pitch be. Pitch means nothing but bolt to bolt distance, bolt center to center distance. So for that, I am calculating 210 by 2. That is 210 is nothing but already we provided the distance, that is provided depth 210. So 210 by 2, that is 105. So force due to moment in extreme bolt. So in extreme bolt, force due to moment. So I am calculating mr by sigma r square is the formula. So moment already we calculated. R is we know that 105 and divided by summation of r square. Two r's are there. 105 square plus 105 square. I got 58958. So after that, I am calculating resultant force. resultant force is nothing but adding these two values. Okay, we know the formula, f1 square plus f2 square root over, so 5833.3 square plus 58958 square. So I got 592458, which is greater than our bolt value. Hence it is not safe, because our bolt value is 45272, but the force is force acting on that bolt is 59245.8. Hence it is not safe. So that's why for safe side I am providing 5 bolts. Okay, instead of 3 bolts, right now I am providing 5 bolts. So for same calculation I have done 70,500 divided by 5, so I got 3500. Force due to moment, again I calculated the moment. So here moment into 100 is nothing but actually the plate distance is like this. I mean the arrangement of this plates is like this. I will show you. Okay, if suppose this is our ISMC channel, here the distance, the plate distance is like this. So here the overall distance is, the spacing of this distance is 220. Okay, in this we need to calculate the moment. Right now already calculated the moment, and 100 is in this half of this I am taking 110. Okay, like that I am calculating 2 into r square. R square is nothing but 50, means if the total distance is which we provided is 270, okay, and edge distance is 35 and 50 total 450s, and here from edge distance is 35 from bolt to, actually I'll draw here like this, bolt edge to, so 5 bolts. Okay, like that I'm calculating. So edge distance is 35 plus 35 70, and 450 is 200, total 270. So in that I took like this, 2 into 50 square plus 100 square, that is nothing but r square. R square is nothing but, here we took half of this and the portion is like this. Okay, and this distance is we are calculating and we are detecting these distances. So I got 100 plus 50 square, so 2 into 50 square plus 100 square, so I got this value. Again I calculated resultant force, f1 square plus f2 square, so again I got 49648 newtons, whichever is less than 45272. Hence it is also not safe. Why? Because our bolt value is 45272, but our force is more than the bolt value, hence it is not safe. Then we need to revise the section. So here we need not to revise the section, just we need to change this value. Actually we provided the spacing of the batten C is 1415. Instead of this value, if you reduce this value, automatically you will get the strength value. Okay, if you took C equal to 1200, again you replace the 1415 value with 1200, you will get the lesser value for this. Okay, like that you need to design the batten column problem. Okay, while designing these lacings and battens, you need to follow IS 800 2000 specifications. If you are familiar with IS 800 2007 code book, it is easy to solve the problems. Thank you so much. Thanks for watching.